This session is a bit non-standard, as you'll see, so it's not so much related to showing you how to write Java stored procedures, I will, but it's also very interesting in terms of you to see how is basically a custom JVM implemented in terms of the Oracle database. So for you guys, have you used Oracle database in any of your projects? Yeah, so I expect to know a bit of Oracle database. Have you written some stored procedures in any language, either PL, SQL? Okay, so you know what's the pain there. Okay, so just a few short words about me. If you weren't at my previous talk, my name is Martin. I'm currently a software consultant running my own company called Coffee Cup Consulting. I'm also one of the guys who helps with the organization of various events and meetups of the Bulgarian Java user group. I'm also a big OpenJDK and Oracle database enthusiast, and you can follow me on Twitter. I tweet about conferences, technology, and stuff like this. I also recently authored a book on RabbitMQ. This was what my previous talk was about. So I'm quite fond of messaging brokers in general, and if you have any questions, you can reach me after the talk on that topics as well. And I'm also working on a book for Java 9, which is still uncertain when it would be released and available for the wide public. The plan now is to be available in June, July next year, but that's, I think, not 100% sure. So in this talk, we'll see how to write Java stored procedures inside Oracle database, and we'll start by comparing what's the difference between Java stored procedures and the standard PL SQL stored procedures. PL SQL, as you know, is the standard language provided by Oracle database for writing stored procedures, and it's interesting to see what's the difference between the two. Then we'll proceed by seeing how to actually write stored procedures and how to execute them in Oracle database. Then we'll see some interesting tips and tricks on how to manage your Java stored procedures inside the database. And finally, we'll cover a few new stuff that were introduced in the latest release of Oracle Database 12c in regard to Java stored procedures. So, PL SQL versus Java stored procedures. Both PL SQL stored procedures and Java stored procedures are executed directly inside the Oracle database using utilities provided by the database. And basically both can be recompiled dynamically by the database. If you write, for example, a PL SQL or Java stored procedure and you change it directly into the database, when you execute that procedure, the database may detect whether there are some changes and to recompile that stored procedures. This may affect basically some dependencies that you might have. So for example, compilation might be transitive. The database may decide that it may need to compile some other stored procedures or functions that are used by the ones that you've changed. And also, why would you choose Java instead of PL SQL? For example, if you have some stored procedures, Java stored procedures, and some Java basically code running in your application, such as, for example, some Jdbc logic, and you think that basically there are many network round trips and you want to move that logic to the database directly, it is very easy because you can actually take directly the Java source code that you have and that uses Jdbc and put it in the Oracle database and it will be running. And the reason for this is because basically Oracle database provides a server-side Jdbc driver, so you can use Jdbc inside Java-based stored procedures. And we'll see an example of this. PL SQL source code is executed in a virtual machine that runs inside the Oracle database. It's called the PVM or the PL SQL virtual machine, which is pretty much similar to how does JVM bytecode execute. And the PVM is written in C. Here is basically how, on the other hand, you would like to execute a Java stored procedure from Oracle database. You basically have the Java stored procedure and you need to map it to a PL SQL function or procedure. That function or procedure basically tells us how we should execute a Java method from a PL/SQL source code. When we basically execute a Java method or a function from the PL/SQL source code, it goes through the JVM, which runs inside Oracle database. That JVM determines what is the method that it needs to execute. It must be a static method defined in some Java class. Then it executes that method and returns the result back to the PL/SQL procedure. And this is in general how Oracle database basically executes Java stored procedures. Here the PL/SQL virtual machine interacts with the JVM virtual machine and it exchanges data types defined in PL/SQL and data types defined by the JVM. So there is bidirectional communication here between the two. And the same applies basically when calling the Java method. You can pass variables defined in the PL/SQL procedure to the Java method and return result from the method back to the PL/SQL procedure. We'll see in details how this is happening. So it's interesting basically to see how does such a JVM run inside Oracle database. As you can imagine, inside Oracle database we might have multiple hundreds of thousands of users, and each separate user might be running different stored procedures. So you can imagine that if it was the case that you have to create a new JVM process for each separate user, that would be very, very resource consuming. And for that reason, the JVM process that runs within the Oracle database is highly optimized, and you can create hundreds of JVM processes which are completely independent from each other, and they basically can process Java stored procedures in a very resource effective manner. So the JVM process essentially runs inside the JVM process runs inside the Oracle memory. So when you basically start a new JVM process, it uses all of the data structures that are defined by the database. Basically, the Oracle database uses a custom class loader that allows you to load system classes which are provided by the system JVM running in the Oracle database from the database, meaning that you store system classes inside database tables, and the Oracle JVM allows you to load that classes from the database. And in the Oracle JVM running in the database, there is no notion of main methods. So you don't have applications in the same way as you do with the standard JVM. And the reason for this is because you just map stored procedures to some Java methods. There is no need to have a main method that must be executed by the Oracle JVM. Another interesting thing basically is that system classes, as we already mentioned, these are the JDK standard class libraries, are provided by the sys schema in Oracle. So all of the classes that basically you would use and are provided by the JVM implementation are stored in the sys schema. Also, there are some extensions for this in order to be able to resolve classes. Now we have, for example, a method which is called class for name and schema, which allows you to load the class not only by its fully qualified class name, but also based on the database schema where that class resides. This means that you might have the same class, but in two different user schemas, database schemas, and that class might be completely different. So there is one more layer of namespace inside the Oracle JVM. Also, the Oracle JVM uses the database memory structures to store any data that the Java stored procedure needs to store. There is the notion of so-called system global area and program global area inside Oracle database. And basically, there is a Java cache specifically in the Oracle memory structures that allows you basically to store memory inside the running database instance from your Java stored procedures. And basically also there are some customizations made to the garbage collection process. As you can imagine, basically in order to make it more effective for a single user, the garbage collection actually makes use of the memory, the same memory that is being used by the Oracle database to provide storage for Java stored procedures. Another thing is there is no support for Jndi. At that point, you cannot execute native code from Java stored procedures running into the database. However, you can run JDBC source code as you would do regularly in your Java applications. For that reason, there is a so-called JDBC default connection driver, and you just need to specify that special system driver, which is provided by the Oracle JVM, which uses the server-side Oracle JDBC driver that's part of Oracle's JVM. And also there is another interesting thing called SQLJ translator, which basically allows you to write directly SQL statements as part of your Java source code. And this SQLJ translator basically translates your source code to JDBC calls. So it's very convenient because you don't need to write any JDBC code, but you can embed directly SQL inside your Java stored procedures. Now let's see, basically, having said all of this, let's see how basically we can write Java stored procedures. What's the process of basically writing Java stored procedures? So in order basically to create a new Java stored procedure, you need to create a Java class inside your integrated development environment. Then that Java class needs to have some static methods. And basically, these static methods provide the logic for your Java stored procedures or functions. Then when you do, you need to compile your Java classes and load them inside the Oracle database in a particular user schema. And the way you can do this is either by using this load Java utility, which is provided by the installation of Oracle database, or use a special command called create Java, which basically allows you to do the same. With the load Java utility, you basically provide a class file and a particular user, along with possibly some other options, for loading a particular either source file or compiled Java file inside the Oracle database. If you basically load a Java file, not a class file in Oracle database, that Java file can be compiled by Oracle database before the stored procedure is actually executed. And after you do this, after you load your Java source or class file in Oracle database, you have to map it to a PL SQL stored procedure or function. And you can do this using the create function or procedure command, as you would create a regular PL SQL stored procedure or function. So it's, as we can say, it's a three-step process. So in a bit more detail, the load Java utility basically uses also the create Java command that you may use inside Oracle. And basically you can call create Java with different type of options, such as source, class, or resource, depending on whether you would like to create Java resource inside the user schema, or you want to create a compiled class resource, or you want to load some other resource, such as a properties file or something else. And here is an example of how you would load basically the, for example, sample.java source file. In using the schema of the Oracle user. You would say load Java -u, which is the user you would like to use, and then you specify the Java source file. If basically you would like to load and compile the source file at the same time, you have to specify the -resolve option, which basically tries to compile the file directly when you load it into the database schema. If you don't do this, basically, compilation will be tried right before you execute your stored procedure that uses a Java method from that class. And here is it, how you can map basically a Java function to a PL SQL function. You say create or replace function, the name of the PL SQL function. We return something which is varchar2, which in Java maps to string. And we say as language Java name, which means that this stored procedure will be mapped to a Java function, and then we specify the function signature, which in that case comes from the sample class, so we say sample.func, and we specify the return type of that function, which is string. And this is how we can invoke the created stored procedure. This is just a regular set of lines that you can execute to execute a regular stored procedure, not only a Java stored procedure. We define some variable called result, and when we call this Java stored procedure, we assign the result to that variable in Oracle, and finally we print that result. You can also provide privileges to other users to basically invoke your stored procedures, and in order to do that you can specify the -grant option when you load the stored procedure. In that particular case, when we load the sample Java class, I specify that I want to load it into the Oracle user schema, but I also want to grant permissions to the users, to user to execute stored procedures from that class. I can do the same thing by using the Oracle's grant command, which allows me to grant certain permissions to users. I can say grant execute on the particular Java class to a certain user. And you can, of course, revoke that permission at a later point. Now, let's see how this works in practice. So, let's start with something basic. So, I have really, let me just increase my font. I have a fairly basic Java class with one static method, which basically would be my Java stored procedure. It just does system out print line and returns some static string. As simple as that. So I would ideally like to compile that Java class. And when I do this, I would like to load the compiled class, not the source file, but the compiled class inside Oracle database. For that reason, I have to go to the target directory. Inside classes, I have UA, org, JavaDay samples, and this is my class. So I'll copy this, and basically I've added to my path the load Java utility, which basically provides me with a way to load that class inside Oracle database. So for that reason, I may say load Java -u, and I have a user called demo that I've created in Oracle database for the purpose. I specify the user, and then I specify the full path to that class. Yeah, let me. Sorry? This is something specific to Oracle Database 12c, which means that this is a common user. So in order to denote a common user, you have to specify this thing in front of the user. You cannot just say demo. So basically, this is equivalent to what you say with just a regular demo user. To give you some more background on this, in Oracle 12c, they've introduced something called multi-tenant databases, and they have created the so-called common users that basically allow you to access, from a single user, to access both the CDB, which is the container database, and the child PDBs, which are the multi-tenant instances for that particular database. So for now, you can think of this as just a demo user. And basically, if I execute this, I have to provide the password for my user, and basically I've loaded the compiled class inside Oracle database. If I go back actually to Oracle database, I can create now my stored procedure. For that reason, basically, I can use that command, create or replace function. I'll map it to a PL SQL function called sample function, return varchar2, which is the actually returning string, and I map it to the class, to the function that I've just loaded from the sample stored procedure class that I actually loaded with the load Java utility. So this is how basically you can create PL SQL stored procedure that maps to a Java function. And this is essentially called Java stored procedure. And now, if I want to execute this, I can simply say, for example, select the name of the function from dual. Dual is just the dummy Oracle table that you can use for testing purposes. And if I do this, I can see that I get the result, which is the return from my Java method here. This is a simple Java stored procedure. Now, you may think of where is this system out print line? I don't see it here in MySQL developer. This is actually Oracle SQL developer. If you've been working with Oracle database, you've most probably used that tool. So basically, in order to enable the printing of system output, you have to specify a switch. You have to enable server output. Sorry? Yeah, it's fine. Yep. So if I basically enable this and run the function again, I have to also enable the output DBMS output buffer here. No, I think I have a mistake here. Okay. Okay, I have a cheat sheet for the purpose. So, okay, as you can see, here is the system out that's being printed. If I execute it once again, and I enable DBMS output, I should see basically that the system out print line is printed as a result from the script output. So basically you have to enable system output in order to be able to dump system out print line inside Oracle SQL developer. This is good to know because it's useful for debugging purposes. As we'll see in a few minutes, basically we also have a way to debug our Java stored procedures if we need to, but sometimes it's really convenient to have system out print lines, as you would do in a standard Java application. So now let's see a bit more of a complex example. I have some Jdbc stored procedure, which is a Java static method. I create a connection by getting the default driver, which basically will refer to Oracle Database Server Jdbc driver. Then I create some SQL string, which is to select the name column from some database table, which I specify as function parameter. Then I create standard Jdbc statement. I create a result set, and I iterate over the results and print out the values from that query, for the values for the name column. And basically, I would like to execute that Jdbc stored procedure inside Oracle database. What I have to do basically is to load the compiled Jdbc stored procedure class again using the load Java utility. So if I go back here, I'll copy the directory of my class file. I'll go again from the command line. I'll say load Java -u and specify the demo user. And then I'll specify this Jdbc stored procedure class. Okay, so now that I've loaded it, I would like to create the mapping from PL SQL to my stored procedure. And I'll do it in a very similar way as we basically did with the simple function. I'll say the following create or replace procedure, specifying the name of the stored procedure, which is sample procedure Java. Then I specify some mapping type, which is basically a function parameter that will map to the parameter specified by the Java stored procedure, which is varchar. So this maps to the Java stored procedure parameter. And I also specify the signature of the Java method that I would like to map to. As you can see, basically I specify the fully qualified name of the class followed by the method and the types of the method parameters. I can have one, more, or any type basically. If you are actually thinking of how an Oracle data type maps to a Java data type, you can refer to Oracle documentation. They have described very well how basically each particular Java type maps to an Oracle type and vice versa. So you can use it as a reference. Now if I basically create that sample procedure and I would like to test it against a table. So for that reason I've created a users table which has a name column. And just before executing the stored procedure, let me query it. Select name from users. Pretty simple. I have three rows, 3 different users with 3 different names: Jim, John, and Jack. And now I can execute that stored procedure and basically specifying the name of the database table as a parameter. I can make it even more simpler. I'll specify the users table as a string parameter. Okay, so I like this. Okay, I think I don't need that thing here. And as you can see, as I execute basically the stored procedure, I just using the system out print line, I print this from the Java stored procedure. This is the system out print line, which I had in my Jdbc stored procedure here. So as you can see, basically you can directly execute Jdbc code inside the Oracle database in a very similar manner as you would, for example, write a PL SQL procedure that executes some SQL query inside the PL SQL procedure. However, there is also the fact that there is some additional interaction between your Java stored procedure and the Jdbc driver, but the fact that this is running inside Oracle database already makes it quite more performant than you would execute that query over the network. This is especially useful for some stored procedures that, for example, process a lot of data and return just some small result. And in order to avoid basically sending data through the network, you can just have a Java stored procedure. As an alternative, if you don't want to write a PL SQL stored procedure. So this is how you can write Java stored procedures in Oracle database. And now let's see basically how you can manage those stored procedures, because it's important to not only know how to write and change stored procedures, but also how to manage them if you need. So basically there is a user table called user objects that allows you to list all of the currently loaded Java resources in your user schema. So for each specific user that runs currently the database, he can basically make a query on this user objects database table and get all of the Java classes or Java sources or resources that are inside the Oracle database. You can also use JMX to monitor what's happening inside a particular JVM instance for a particular user, as you would basically do with binding to a JMX server running on a standard JVM. However, in order to be able to bind via JMX, you have to be granted the JMX server role. The other interesting thing is that in order basically to be able to create a JMX server inside the JVM running on Oracle database, you have to use a PL SQL stored procedure which is coming from the RDBMS Java package, and that procedure is called start JMX agent. This is basically what you need to do in order to start JMX server in Oracle database. You can also debug Java stored procedures inside Oracle database And basically the JVM implementation of Oracle provides JWDP, which is basically the standard compiler debugger interface in Java. And basically any ID, such as, for example, Eclipse or JDeveloper, has support to plug into the Oracle database and to debug your stored procedures. Yeah, and basically in order to debug, you can use the connect TCP function that will allow you basically to connect to a debugger running, for example, in your ID. So when you basically execute that line, you can connect your debugger to that port on that host and start debugging stored procedures. Yeah? Mm-hmm. Mm-hmm. Yes. Mm-hmm. Yes, yes. So from your ID, when you execute this, you can connect to this. And when you execute, basically, when you place a breakpoint in your ID to some static method Java that you want to debug, and basically when you bind your remote debugger to Oracle database, you'll be able to debug it. With PL/SQL, there is a PL/SQL debugger provided by Oracle database. With the PL/SQL debugger, you can just go to your, let me see if I can have some procedures already. For the PL/SQL source code, you can place breakpoints directly in Oracle SQL Developer and debug it. So, or you can use an ID, such as Oracle's JDeveloper ID, which is another ID not related to Oracle SQL Developer, also provides you with debugging capabilities. But for PL/SQL procedures, you can debug them directly from here. To debug them, it's basically the same question. So you can directly debug by placing, because when you create a stored procedure from Oracle SQL Developer, you can see it here under the procedures tab. And when you go inside it, here I have a very simplistic, which is a Java-based stored procedure. But if you have a more complex PL/SQL procedure, you can just place some breakpoints and debug it directly from here. No need to have some other ID or tool that you need to use. So it's very convenient because at some points, typically, if you don't or you cannot use just plain simple system out print lines, it might be more convenient to use the debugger. And also, when you compile Java stored procedures, you may specify some compiler options. By default, when we load it, the Java class file, it was already compiled. But if we loaded the source file, you may need to specify different compiler options. For example, you can think of any of the compiler options currently supported by the standard JVM. In order to do this, we have a couple of options. One is basically to specify those compiler options when you load the source file using the load Java utility. Another one is to modify directly the Java options table, which basically stores any JVM specific settings. And the third option is basically to use functions and procedures provided by the RDBMS Java package, which basically operates directly on that Java options table. But they are more convenient to use than writing queries to update this Java options table. So these are three ways you can specify compiler settings. And as a very brief demo, I want to show you basically this user objects table. So I can select from user objects. And I can see that I have many object types. I currently don't query based only on Java object types, but as you can see at the beginning, I have a lot of Java class object types. And the reason for this is because I've loaded the RabbitMQ Java client library in Oracle database, and I have a lot of classes. But if I want to make a more fine-grained access, for example, I want to check how does the Jdbc stored procedure that I loaded looks like. I can filter by object name. Let's say where object name like Jdbc. And I can see I have two lines here. Do you know why I have two lines? I loaded just one class. Can you suggest why I have two lines? Yes. I have loaded it 2 times, but the first time I loaded it, it was with a different package name. And I haven't deleted it. So as you can see, the package name here is hashed, and it's appended to before the simple class name. You don't see here the fully qualified name of the class that I loaded. Another interesting thing, you can see the object type is Java class, so I already loaded a compiled Java class. You can see when it is loaded. You can see whether it's valid or not. This means that if I load a source file and it cannot be resolved, it cannot be compiled, this will be marked as invalid, meaning that I have loaded the object inside the database, but it's actually not a valid Java source or class file. And a few other fields which are not really that important. So basically you can use the user objects table to query your database objects, and the JDBMS Java package provides you with a lot of other useful methods that you can use, for example, to debug the database, or to specify some compiler options, to tune the JVM, to specify some access permissions, because you can use the Java security model here directly. Oracle's JVM provides a custom implementation of a security manager that allows you to specify permissions of what your Java stored procedures can or cannot do. For example, whether a Java stored procedure can open a socket connection, or whether a Java stored procedure can write to the file system. This is controllable from the JVM instance running inside Oracle database using the standard permissioning mechanism that you have with the JDK. Yeah. Mm-hmm. Yes. Yes. If basically you want to query something from schema B, and the user that currently executes the stored procedure in schema A doesn't have the permission, you'll get an error that you don't have permission. You'll get the same error you would get if you try to execute directly that query. Yeah. You can grant basically permissions to other users to load classes loaded in your schema. Because when you load a Java class, you load it in a certain schema. You specify the user, and each user in Oracle database has a separate schema, unless you create another one. Mm-hmm. So basically what you're trying to say is that you, for example, you have the permission to execute a stored procedure in schema B, and that stored procedure actually tries to access some database table for which schema A doesn't have permission. What would happen in that case? Typically, you would get again permission exception because the current user that executes the stored procedure which is defined in schema B doesn't have access to that data structure. However, when you create in PL SQL a stored procedure, you can specify which user should be considered for security reasons, whether that should be the user that executes currently the source code, or whether that's the user that has defined the stored procedure. So if in schema B you say that when you want to execute that procedure in schema B, the permissions should be the permissions of the user that created that procedure in schema B, then you would be able to do whatever you want in schema B. It is possible. Why? Because when you execute the stored procedure in B, you have permission to execute it, right? Yeah. But you don't have permission to access a certain table in schema B, and that table is used by the stored procedure in schema B. Yeah. But when you execute the stored procedure in schema B, you'll still get an access permission exception from Oracle database, because when it executes the source code, it will determine that user A doesn't have permission to access that table defined in the second schema. Basically, the grant revoke mechanism in Oracle database applies here as well. No? Yeah. You can do it using basically the same mechanism I've shown. For example, if you have a Java library packaged in a jar file, you can use the load Java utility to load jar files as well. And Oracle database will load all of the classes in the Oracle database, and from there you can map whatever functions you have in that library. Yes, that's basically the same mechanism. In the current schema, and this is the object type. It's an object in the same way as you have a database table or a trigger or a sequence. You have other types such as Java class, Java source, and Java resource. It's just an object type in the database. Yes, you can view triggers from here. So it's more of a matter of preference. So basically, whether it's PL SQL or Java, both will do the job. If you're a Java developer, you may prefer to write Java stored procedures and execute them. If you want to go more with the Oracle way, you'll write PL SQL. I think PL SQL is, for me as a Java developer, not so good in terms of syntax. So if I need to do something quickly, I would avoid the hassle of trying to look for some PL SQL syntax or something specific. I'll just write my Java source code and load it and execute it inside Oracle database.
What is the productivity overhead when we are using Java?
There is not, because the JVM basically that executes the Java stored procedure. The only overhead actually is here. And let me go back to my slides. The only overhead is that you have here. When you have a PL SQL code that maps to the Java stored procedure, the only round trip is that the PL SQL virtual machine needs to make a call to the JVM in order to execute that Java stored procedure. And this is the only additional round trip that is made, but it's not so slow. It's actually a fast operation.
If we have a task which extracts a lot of data from the Oracle database, and then processes it in some way in Java, So the best way from the productivity point of view would be compiling Java code and loading it into the Oracle.
Yeah, that will do the job.
And is it possible to choose a JVM version, for example, if I want to use JVM 8 and
This is a good question because I would also get to that point when I talk shortly about the new features and finish with that. Until Oracle Database version 11G, there was a way to specify just one version of the JVM for that should be used for all of the stored procedures. You cannot have two different versions of the JVM, for example, in different schemas of the database. So yeah, there is a way to specify which version of the JVM you would like to use, but up to Oracle 11G, there was just one JVM version shipped with Oracle database. And if you want to switch to another one, you have to manually provide installation of that version to Oracle database, which I haven't tried, but should be possible. However, since you're getting to the point, in terms of new features, this is my next slide, there is a support for multiple JDK versions provided. So in 12c, you can basically specify whether you would like by default to use JDK 6, 7, or any other type of JDK. And it's much easier than you would do with earlier versions of the database. You just need to specify an option that says which version of the JDK you need to use. Another new thing, basically, in terms of what I mentioned earlier about multi-tenant databases, is when you define basically a JDK version over the master database, that version is used on all of the child or multi-tenant databases. Another new thing is native support for Jndi. So you can bind Jndi objects inside Oracle database and retrieve them as you would use Jndi, for example, in a JavaE application. And also we have the ability to customize the Java security resource, which is basically the ability to specify where to load security permissions from in general. There are also some other things, such as, for example, enhanced support for logging properties, some more secure use of the ability to create external processes using runtime exec, and some more improved debugging support inside Oracle JVM. And that was it. Any more questions?
Is it possible to use some kind of external libraries, a complex one, as a Spring, for example, Spring Jdbc or?
It was the same question as his, basically. Can you?
No, not the question. It's not. Is it possible to implement such complex dependencies on practice, or it is only restricted by one or two jars?
Yes, so basically if you, for example, if you want to use the Spring library and it has a number of other dependencies, the only way I know is basically to manually load those dependencies inside the database schema and then load Spring framework. Or you can basically load them in a different order, but in order for Spring framework to resolve, it needs to find the classes of those dependencies inside the database schema. So you need to load them manually. But there is no way, for example, like some utility like Maven, for example, where you can specify I depend on this, and Oracle database just goes, fetches them from some server, downloads them, and you have it in the database schema. You have to do it manually.
Application in one jar file.
Yeah, of course. If you assemble it in one jar file, you can load it at once. Yeah.
Okay, thank you.
Yeah, welcome. Okay, and I think we're close to the end. So thank you for attending this talk. You were a small but very vibrant audience. Thank you for this. And I wish you a pleasant evening.